In this video, we'll present the solutions to the multiple choice questions from the 2016 winter exam, questions 6, 9, and 10. We'll start with question number 6. This problem has two improper integrals involved. The first one is obviously improper because it has an infinite quantity, and again, an improper integral is one that has some kind of infinite element in it. The other one is less obvious. However, if you look at x equals 0, and the value that the integrand takes on there, we have a 1 over 0 value, which is undefined. And so it is also an improper integral. If we look at the options we're trying to decide between, we're essentially being asked whether these integrals individually converge or diverge. And remembering what that means, converge means equals a finite value, a single finite value, and diverges means not that, or not converging. The simplest way to assess that in this problem is just to go through the steps of an improper integral. Specifically, starting with the first integral here, we rewrite it as the limit of the integral from 1 to some number. So instead of using an infinite quantity, we use a finite number. And because we're going to be integrating, it helps if we rewrite our integral as a power. We can then add 1 to the power and do all those kinds of tricks for the integration step. We also then have to ask the question, what happens if this finite value eventually got larger and larger and larger? So this is the area under the graph from 1 to b, and this is 1 over root x. It looks like one of these asymptotic kinds of functions. So the idea is if we have a 1 and a b as finite values, then the area underneath the graph is definitely finite. So everything in the brackets here is finite for sure, and it equals an area that's going to depend on where we stop measuring our area in the integral. And then we ask, well, what if b got moved out further and further and further? And that's what this limit question does. Once we have the area up to b, we just ask what happens if b was higher and higher. So we continue with the calculations. The power x to the negative 1/2 when we integrate gives us x to the positive 1/2 divided by the new power 1/2 between b and 1. That's the limit as b approaches infinity of 2 times, what do we have here? We have 2 times root b, plugging the b into here, and then plugging the 1 in. Technically the square root of 1, which is also 1. And then we ask ourselves what happens as b approaches infinity. And in this case, this b is in the square root, but if we take the square root of larger and larger and larger numbers, that's also going to go off to infinity. So it doesn't equal anything, but actually heads off to infinity as well. So the area goes to infinity, which means that the integral from 1 to infinity of 1 over root x dx diverges. Repeating the same calculation for this integral, it's the same idea except the 0 is a problem point. So the 1 is fine, we can integrate or evaluate this at 1, but we can't plug in 0, so we sneak up on the 0 point, and let's actually use a different variable. We'll call it a this time, just to clarify the difference. Notice the integration step is going to be exactly the same because 1 over root x is x to the negative 1/2. That's the same as we did before. So we can be a little more efficient here. Integral will be x to the positive 1/2 divided by 1/2 between 1 and a. And that'll be 2 times. Top value first, we get square root of 1 minus next value, square root of a, and this, when we evaluate it as a approaches 0, that's totally fine. This a value, square root of 0 is just 0, so that term just approaches 0, and we end up approaching the value 2. Totally fine. So this converges. Integral from 0 to 1, 1 over root x dx converges. What does that leave us with? Well, it leaves us with diverging for the first, converging for the second, The correct answer is C. Note it's a multiple choice question, so you don't have to go through all these details. It's good practice to use this limit definition in case you have other improper integrals that are part of a long answer question, though. In question 9, we are given a surface and a series of formulas that we can try to match to it. The first thing to notice is that all of the expressions have a sign x squared plus y squared. So they all have that sine function in it. The next thing is that they all have x squared plus y squareds. So they all have circular symmetry. So we're not going to get any clues from those to help identify this function. However, we do have other techniques we can try. We can let x or y equal 0. Why don't we let x equal 0? So we can do the y if we want later, though there's not much point because everything's going to be the same along x and y. So we let x equal 0. And if we do that, we get a series of graphs. So I'm just going to erase these comments here. If we let x equal 0 for each of these, we simply get sine of y squared. This becomes 1 plus x squared sine of y squared, and my apologies, that should be a y squared. X is 0. And this becomes e to the y squared sine of y squared. And 1 over 1 plus y squared sine of y squared. Okay. Some people at this stage here can recognize the correct answer. The idea of the circular symmetry is that whatever happens along the y-axis, whatever shape we get there, is then just rotated around to make a circular pattern. And if you consider these 4 functions here, they all have peculiarities, and only one of them is going to match the shape of this graph here. Specifically, if we take a look at the term in front of the sine function, there's effectively a 1 in front of that, 1 plus y squared, e to the y squared, and the fraction here. The key to remember is that those are the amplitude of the sine function. And if those are the amplitudes of the sine function, well, in the first case, our amplitude is always 1. What would that look like? It would look like this, and then be spun around. Our amplitude is definitely not doing that. It is changing. We have an amplitude that's high, and then lower, and then lower, and lower. So it's definitely not A. What does that leave? Well, B, C, and D. If we take a look at the next two, though, these have amplitudes that grow. This and this. They grow as y increases. As you move out this way, these amplitudes will get bigger and bigger and bigger because y squared increases, e to the y squared increases, and so that doesn't fit with what we want in our particular scenario. Whereas the 1 over 1 plus y squared shrinks. This decreases as y increases. And that's the amplitude that is decreasing, so that matches perfectly with what we're seeing in the graph. So here the correct answer would be D. In question 10, we're asked which sphere would just fit inside the cube defined by a series of planes. One of the key elements here is not to overthink it, not to make it too complicated. Let's take the z's as a sample point. What we're saying is there are 2 planes, one at z equals 3 and one at z equals 7. Guess where the center is? Halfway in between at 5. If you must use formulas, you can absolutely do that. The average z would be the sum of the 2 values divided by 2 to get an average, and that would give you 5. I think it's overkill if you can see it on a diagram, though. Next question, if we have a sphere nestled in there, what's the radius going to be? Well, it's going to be 5 to 7 or 5 to 3. That radius is going to be 2. Once we have that idea, we can look for the center in x. So let's do the whole center this way. It's going to be at x equals -2, halfway between -4 and 0. The y center is going to be at 1, and the z center we just set is 5, and radius 2. Then all we have to remember is the formula for a sphere is like Pythagoras, except we have a z as a third component, but it's x distance squared plus y distance squared plus z distance squared equals r squared. And the key thing is the negative in here. So x minus minus 2 will be x plus 2. So it could either be A or C, but can't be B, cannot be D. And just to confirm, y minus 1, good. Z minus 5, good. And then radius squared. In our case, that's 2 squared, which is 4. So we're looking for this one. So it's not C. So we're looking for A as the answer to that problem.